Welcome back, Lesson 9, and this one's about putting a real web application firewall at the edge. Last lesson we handled, UHO connects with mTLS. Now we're inspecting what they send. ModSecurity is the engine. OWASP CRS is the rule set. 2,000 plus rules covering SQLi, XSS, RCE, the whole OWASP top 10. But here's the catch. Flipping it on in blocking mode will break legitimate traffic. The craft is detection only first, tune the false positives, then enforce. 4 pieces, 1 discipline. So let's name those 4 pieces. ModSecurity 3 is the engine, a C++ rewrite that ships as a dynamic Nginx module, controlled by 3 directives that inherit cleanly through HTTP server and location blocks. OWASP CRS is the brain on top, score-based, threshold-triggered, with paranoia levels 1 through 4 that dial how aggressive you want to be. DetectionOnly is your safety net during rollout. Log everything, block nothing, until the audit log is quiet. And exclusions are the scalpel. SecRule remove by id on a specific path, not weakening the whole config. Skip any one of these and you either get owned or you 403 your own users into oblivion. Now here's how a request actually moves through that engine. ModSecurity runs 5 phases, and every rule is tagged to fire in exactly one of them. Phase 1 sees the connection and URL, cheap stuff like GeoIP blocks and scanner fingerprints. Phase 2 is where the body gets parsed, and that's where the bulk of CRS lives. SQLi, XSS, RCE patterns. Phases 3 and 4 flip to the response side, catching leaked stack traces or data exfiltration. Phase 5 is logging, after the bytes are already on the wire. The operational win? Block at phase 1 or 2 and you never touch the back end at all. With the phases clear, let's actually get this thing on the box. 2 halves. apt installs the dynamic module and drops the load to module line for you, and a git clone pulls down the OWASP core rule set. Then you stitch them together in a main.conf, baseline config, CRS setup, and the rules glob, and flip it on inside your server block. Critical detail, that baseline ships in detection-only mode. After the reload, you have a fully live WAF that logs everything and blocks nothing. That's exactly where you want to start. And detection-only isn't just a default. It's the entire rollout philosophy. 4 phases. Log everything for a week, tail the audit log to find which CRS rules your legitimate admin panels and SQL builders are tripping, write surgical per-path exclusions that disable one rule ID on one URI prefix, and only then flip the engine to on. Skip the watching phase and you'll be rolling back at 3 in the morning while support tickets pile up. The discipline here is what separates a WAF that protects from a WAF that gets disabled. Once you're past detection only, tuning comes down to 2 dials. Paranoia level controls how aggressive CRS is. Level 1 catches the obvious SQLi, XSS, and RCE with around 0.1% false positive rate, and that's where most production apps should sit. Level 4 rejects anything that smells funny, and you only run it on lockdown APIs with very clean traffic. Then the anomaly score threshold decides when accumulated rule hits actually block. Default of 5 means 1 critical rule trips it, or a couple of warnings stacked together. And when something legitimate trips a rule, you reach for exclusions, but per path with CTL rule remove by id, not the global SecRule remove by id sledgehammer. So here's the whole picture assembled. Load module at the top of nginx.conf. Then inside the server block, you flip ModSecurity on and point at main.conf, which itself pulls in CRS and your global exclusions. Every location inherits protection by default, but notice the SQL builder endpoint. It gets an inline ModSecurity rules block that drops the libinjection SQLi rules just for that path because that API legitimately accepts SQL. And audit logging lands in its own file, so attack forensics never gets buried in your access logs. Now let's step back and answer the question some of you are already thinking. If my app validates input properly, why bolt on a WAF at all? 3 reasons. Defense in depth, because the next CVE in your framework drops on a Tuesday, and the WAF buys you patching time. Centralization, one config at the edge protects 12 microservices instead of every team reinventing input validation. And finally, operations craft. A WAF you don't tune and monitor is just security theater. It's a discipline, not a switch you flip. Speaking of discipline, print this slide. These are the 7 directives you'll actually reach for. The top 2, ModSecurity on and ModSecurity rules file, live in your Nginx config and wire the module in. SecRuleEngine is your rollout lever. Detection only. First, then on. SecAuditLog tells you what fired. Paranoia level tunes aggressiveness. And when you need exclusions, prefer CTL rule remove biide, scope to a path over nuking the rule globally. Surgical beats sledgehammer every time. Theory's done. Time to actually run this thing. 3 drills in order. First, install ModSec with CRS and DetectionOnly and fire a fake SQLi at it. The request succeeds, but the audit log shows rule 942100 matched. You've watched an attack without breaking anyone. Second, flip SecRuleEngine to on and rerun the exact same curl. Now it's a 403. Third, trigger a false positive on a legitimate search query and write a path-scoped exclusion. Do all 3, and you've operated a WAF end-to-end. Now that you've run one end-to-end, let's talk about the ways teams blow it up. 5 mistakes, and they fall into 2 camps. Too strict, where users hit 403s and trust collapses, or too loose, where the WAF is decoration. Blocking from day 1, never reading the audit log, killing rules globally to fix one endpoint, cranking Paranoia to 4 just in case, or skipping body inspection on posts. Every one of these comes from skipping operational discipline. The fixes are in the right column, and they're all cheap if you do them up front. And that's lesson 9. You've got ModSecurity wired in as a dynamic module, the OWASP core rule set loaded, detection only carrying you safely to enforcement, and per-path exclusions keeping the noise down. The WAF is real, the top 10 is covered, and you have the discipline to tune it without breaking production. Next up, Lesson 10, Observability, Prometheus, Grafana, OpenTelemetry. Because a WAF you can't see is a WAF you can't trust. See you there.